Now this is because the whole preview there is in real time. So this is great. Anything you do in the channel graph, you can see the results instantly in the bottom left here in the preview, or if you want to see it bigger, you can just use the tab here to see it full screen. So let's go back to the channel graph and look a bit closer at the way it works. So as I said previously, this is set as our start 3D scene, so everything is running from here and being called from left to right. If we went out to change this and set our cube as being the start channel, by right clicking on it and going set as start channel, you can see we now still see our cube here, but its visual properties have changed quite a lot. You can see now it's no longer illuminated because the light is no longer being called. It's no longer part of the project. Our scene is starting from here now, so the only thing that's happening is this directory is being called, then our surface is being called, and then that's going over and over again. So let's go back and set our start 3D scene as the start channel. We'll now take a look at how you can link channels. Let's now take a look at how channels are linked. Before we do this though, it's important to understand the difference between parents and children. Now you can see most of the channels here have other channels connected both beneath them and above them. So with our render channel, for instance, it has a single parent, the parent being the start 3D scene, and it has three children being the camera, the cube and the directional light. So when we're talking about parents and children, it basically means which channels are connected below it, they're the children, and which channels are connected above it, and that's the parent. Let's now add another object to our scene. So if we go over to the templates and go down to primitive object and drag that into our channel graph, you can see now we have another object in our scene. At the moment this object doesn't do anything because it's not connected. So to make it part of our scene and make it rendered, we need to draw a link from it up to our render channel. Now there are several ways to do this. The first of which is to actually put your mouse over this node here, okay, which is the channel link position. So you can see as soon as I do that and drag with the left mouse button, a link is being created. Now also watch what happens to the other channels here when I do this. See the colours, there are red nodes underneath this one and green underneath that one. So as soon as you start drawing a link, you see different coloured nodes beneath all the channels. Now these different colours basically tell you where you can connect this channel to. So where it's green you can connect it, and where it's red you cannot. We can connect it up to our render channel because we want to render it. So if we just draw the link and drag it over this node here and let go, you can see another box has been created. This object is now being rendered. So if we want to delete this link, you can just select the link by drawing a bounding box around it, or literally by clicking on this enter there and then pressing the delete key. Now another way to link a child, very similar. This one, you again start drawing a link from the channel link position, but you can also drop it anywhere over the channel, not necessarily on a node, and then it will occupy the first available link position, just like that. Let's delete that link again, and I'll show you a third way of linking up one channel to another. Now this way, all I've got to do is press the L key. I'm now holding the L key down, and then you click where you want to link it to, and it will automatically create a link there. So those are three different ways of creating links from one channel to another. Now as we just saw, it's not possible to link any channel to any channel. Now this is because channels have something that's called a base type. Now a base type basically decides where it can be linked. So for instance, if we put our mouse under the node to our render here, a pop-up comes up telling us which base type of a channel should be connected there. So this is telling us that we should only connect channels with a base type of 3D object. Now if we put our mouse over a channel, you can see this pop-up will come up again and it will tell us the base type of this channel. So in this case these are both 3D objects, which is why we can connect them up there. We also have a channel type, which is something else. Now a channel type is totally unique to that particular channel. So every single channel has a unique type, but the base type basically decides where it can be linked. Let's now take a closer look at channeling. Let's now unpack all of the directories in the channel graph and have a look at how this project works. So let's make a bit of space here and move things to the side. Okay, let's first take a look at the camera. Now you can see the top channel we have here in our camera is just called a camera channel. Now if you press F1 on this channel with it selected, you can see a help comes up very specific to that channel. It tells you which children should be connected and the functionality of every individual child. So you can see here it says the first child of our camera channel should be the matrix. So if we look here, you can see we have a matrix here. Same thing with the matrix channel. If I hit F1 on that, it tells me exactly what this channel does and what children it should have. So this is really useful. If you're ever confused about a channel or need to know what should be connected or what its functionality is exactly, just select it and press F1 and you can find out all about it. So with our camera, we have a matrix here, which is basically a channel containing all of the information about its orientation. So its position, its rotation and its scale. That's defined by the three vectors here. So you've got the position vector here, which has X, Y and Z values connected to it. The rotation vector, which again has X, Y, Z values, and the scale, exactly the same thing. So three vectors which contain that information, and that's all held within our matrix. We also have another value here, a value channel which is used for the zoom factor of our camera. Now if we look at our object here, the cube object, you can see it has exactly the same thing as its first child. So if we press F1 on the object, you can see its type is 3D object and its children, again, first child being the object matrix. And then you have a few more options there which we'll look at in a minute. So let's not look at the motion again, let's go over to the surface, and you can see we have the surface channel here, and the surface channel has its first child being an object data type. So basically this is all the information about the geometry. The second child of the surface is the material channel. The material channel also uses vectors, but it has vectors for diffuse, emissive and specular, and these define the way in which this material reacts to light. We'll look more at these values and what they do when we go to the object section in a minute. Let's look a bit closer at the object data channel. Now as I said previously, the object data channel defines the geometry of an object. In this case we're using a primitive object data, so if we double click it, you can see I've got a drop down list of lots of different primitives I can choose from. So previously we were using the box primitive. Now I've gone on to the torus primitive, and you can see here we have a value channel which defines the subdivision level or how complex it is. So if I reduce this to something really low like 4, you can immediately see that the shape is much simpler. Take it even lower and you can see it really does look ugly. So let's take it back up to something like 32 subdivisions. Okay, now let's have a look at our light. So the light, again, it has a matrix. Same with the object and camera. You can see also there's a couple more vectors here. Now these vectors are actually for defining the color of the light, firstly. So again, you've got 3 different values here for R, G and B. And then you've got attenuation. Now attenuation is basically how much the light falls off. And you've got a series of other values here. These are usually pretty unessential. If you want to look further into these, you can press F1 on the light and find out what each of these values does. What I want to do now is look at how you can create a relationship between different motions. Now if we have a look at the motion of our torus object here, you can see the last 2 child link positions are unoccupied. Now both of these have a function. If we put our mouse over one of these, you can see that the first one here is a lookat matrix and the second one a parent matrix. Now let's look at the lookat matrix first. What this allows you to do is have one object look at another one. So for instance, if we wanted our camera to look at our torus object, what we do is we create a link from the lookat node on our camera's matrix directly to our torus here, and you can see immediately the angle of our camera has changed and it's now got our torus in the center of the screen. Now if we just go to the animation section and have a look at this a little more closely, you can see what's happening here. So if I move my torus object around, you can see what's happening is my camera is tracking it. So wherever it moves, it's always looking at our torus object. Now the second child link position we have here is for parent matrices. Now what a